folks, this is Miss Gray,
And this is Mrs. Uy.
and we'd like to welcome you to Unit 4.
Yes, we're now going to talk about periodic table. The title of this unit is periodicity.
So we want to see how do we organize the periodic table, and let's talk about how it's arranged in rows that go up and down.
Okay.
Vertical means up and down. All right, so what do we call these?
Elements with similar
Columns.
properties were placed in vertical
Groups.
groups or families, right? That's great.
Yeah. And this is based on similarities. Like in my family, we all look kind of similar, you know, with dark hair and the same color eyes. And so a family of elements would have similar chemical properties.
They're arranged in vertical.
Right. So here's an example of group 1, group 2. If you see them in the same up and down row, that's called a group
Group.
because they react in a similar way.
Okay. And it's
And we'll move on to going side to side. Horizontal,
horizontal arrangement.
it means side to side, right? Okay, so what do we call the rows?
And we call them periods.
Right. So if it's up and down, it's called a group. Side to side, it's called a
A
period.
period.
Okay, well,
Example.
let's see. Period 1,
Period 1.
2 starts with a lithium, 3
Period
with
3.
sodium. And these are grouped together because their electrons can be found in a similar place.
Okay.
In the principal energy level of 1, that's where you find their valence electrons.
All right.
Then principal energy level 2,
2.
their valence electrons are in the second energy level, in the
Okay.
second ring. All right, so let's talk about,
Families or groups.
right, the specific families we need to know.
Okay. First
Okay.
group, we call them the alkali metals.
Right, these are the ones on the far left. I have to
Okay.
think, left, right, yeah.
Yes,
The far left.
All right.
So lithium, sodium, potassium, rubidium,
Rubidium,
cesium, and
cesium,
francium.
francium.
So these are the alkali metals you need to know. Group 1 is called alkali metals because this is going to be important later on.
Yes.
Here's what they all have in common. They all have exactly 1 electron in the valence shell. All right?
Or the
Now,
outer shell.
our students have already studied in Unit 3 how to write electron configurations in the Bohr model.
Yeah.
So they know what a valence shell
Yeah,
means.
for sure.
Right? And they've probably noticed by now that all of those in there fill in 1 in the s orbital.
And they're very, very reactive.
Yes, right. So you won't find pure sodium out in nature because it's too reactive. It reacts with water, it reacts with oxygen.
Yes.
So it can't just be out in the atmosphere in the environment.
Yes, exactly.
Okay, now we'll give you guys a website to go to here, or we'll show you this one in class, but we don't get to look at this today.
Okay, so
Sadly.
sad that.
I know. Okay, let's look at group 2.
All right, group 2.
So right next to the alkali metals, what do we call these guys?
The alkali
Alkaline
or the alkaline
earth.
metals.
Yeah.
And members that belongs to this group or elements that belongs to this group starts with beryllium, magnesium, calcium,
And then strontium, barium, and radium.
radium.
So these 3, calcium, strontium, and barium, they're important in the solubility rules. So your larger group 2 metals, those are going to be important too. All right, these guys all have 2 electrons in their valence shell.
Yes.
So when you look at their Bohr structures, they all look very similar on the outside
The
ring.
outside.
These are also
Very
not usually
reactive.
found because they're very reactive. They react with the environment around them.
Yes.
All right, group 18. So we're going all the way across
All
to
the
the
way,
right-hand side.
yes, to the right side.
Yeah, these guys, our students already know what they're called.
Yes.
The noble
Noble
gases.
gases.
So these are the ones that have a complete valence shell.
Complete.
So they don't react
complete.
with anybody. 'Cause-
Or they have 8. Right,
Right.
Ms. Gray?
Yeah, so
Or
helium
complete.
has 2 electrons, and these guys will have 8. Yeah.
Okay.
And this has 8, and that has 8.
And then has 8.
Yep. So since they already have a complete valence shell, they have no need to share electrons with anybody else, and they've also got no need at all to give any away,
Yes.
except so they don't react with anything, except for there have been a few compounds made with xenon. but not until 1962.
1962.
You know, one of the fun parts about being a chemist is getting nature to do things it wouldn't not normally do.
Yeah.
Right? So that's why they get paid the big bucks. Because if we only
That's a
ever,
very exciting job too.
Yeah,
I
if
think.
you only ever had what normally occurs,
Yeah.
then that would be boring. Got to pay someone to get something to happen. Doesn't normally happen.
Huh.
Okay, group 17 is right next to the noble gases.
Yes.
So they're nearly at the configuration of a noble
Yes.
gas.
We call them the halogens.
Right. And since they are almost noble gases, they're very reactive too. They have 7 electrons in the valence shell,
Yes.
and so they just need one more
Mhm.
to be complete.
To be complete.
Right.
Yes. So they react easily. to-
Yes, especially with metals that easily give up an electron.
Okay.
So the compounds that these guys form are called salts,
Salts.
right?
All
And
right.
not just sodium chloride, but lots of other kinds of salts
Yes.
too. All right, let's look at another kind of metal. These we'll find in groups 3 to 12.
They're in the center of the periodic table, right? Ms.
Right,
Greg?
exactly. And
Periods
only periods
4
4
to
to
7.
7, because there's that big gap in periods 1 and 2.
Yeah. Mhm.
Right, so these are called transition metals. I'm writing so crookedly. And the transition metals could have 1 electron.
Two.
If it's copper and chromium
Yeah.
families, remember those weirdos?
Yes.
Most of them have 2 in the
2.
valence shell because the s electron
Mhm.
orbitals have 2. But sometimes they can have 3 electrons there
electrons.
because they're transition metals. They can move electrons around and take on different configurations
Yes.
depending on what is around them.
Yeah.
All right, these are the hard metals. The alkali metals and alkaline earth metals, those are softer metals. These are the ones you can hammer into sheets and pull into wires.
Yes.
And we often mix them with other metals.
Other metals, and we can form alloys, right?
Right, like sterling silver or pewter or
Pure.
brass.
Yeah.
Right, and they're more useful that way.
Okay.
All right, well, here's our last thing that we wanted to show our students is that there's a lot of elements on the periodic table. And I'm going to offer a free homework pass to anyone who can sing this song entirely from memory.
Okay.
Okay?
Huh.
Yep.
That's
So
exciting.
let's have a look see here. If you can memorize the song, then you get a homework
Memorize the
pass.
song, and then yes, you can sing it in front of Miss Gray
Yes.
without looking at the periodic table.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
That's it, guys.
Okay.
So feel free to download the lyrics or get them on my website. But if you want to sing it to me in class, you have to have it memorized.
You're going to
And
get?
You get a homework pass.
Yay.
And, you know, you can put your own music to it if you want to. Make it
Yeah.
a rap. I don't care. Just has to be from memory.
Yes.
All right, that's it for this podcast. We'll see y'all in class.
Yeah.